When we talk about AI, our minds usually jumped to the digital world, right? Things like writing emails, creating images, that sort of thing. But what if I told you its biggest, most profound revolution is actually happening in the physical world? Well, based on a fantastic paper from CIRP Annals, we're going to explore exactly that, how AI is literally jumping off the screen and onto the factory floor, running the massive, complex systems that build our entire world. So let's just get right into it. Think about this. It's one thing for an AI to make a little typo in an email. No big deal. But it's a whole other universe for an algorithm to miscalculate the operations of, say, a 10-ton industrial press. I mean, the stakes are just incredibly high. So how is this even possible? How do you hand over the keys to a factory to a piece of software and trust it not to, burn the whole place down? Well, the secret is to stop thinking about a factory as just a building full of machines. Instead, I want you to picture it like a living, breathing organism. It has a nervous system, thousands of sensors constantly feeling, hearing, and measuring every single thing that happens. And right at the center of all of it, you have the AI, which acts as the factory's brain. It's processing all that sensory data and making smart decisions second by second. Okay, so let's look at the first major job for this new brain. Basically, preventing disaster. Because in manufacturing, the number one enemy, the biggest nightmare, is unexpected downtime. One broken machine can grind an entire production line to a halt, and that can cost a company millions. This is where this amazing concept called predictive maintenance comes into play. Now, this isn't like the check engine light in your car that tells you something is already wrong. No. Imagine if that light turned on 3 weeks in advance, told you exactly which part was about to fail, and had already scheduled the mechanic for a time you weren't even planning to use the car. That's exactly what AI is now doing for factories. And the process, when you break it down, is just brilliantly simple in theory, even if it's super complex in practice. First up, data collection. Those sensors are constantly listening to the unique hum, the vibration, the temperature of every single machine. Next, the AI brain analyzes this massive stream of data, and it learns to spot these super subtle patterns that come right before failure, patterns a human could never, ever hope to detect. And third, it delivers what's called an actionable insight. It's not just a vague warning, it's a specific diagnosis and a precise recommendation on when and how to fix it. So the whole point here, the big takeaway, is this. It completely transforms maintenance. You go from this reactive, chaotic fire drill mode to a proactive, scheduled, and super efficient operation. The goal is to make the unexpected, well, expected, and to keep that factory humming along without a single hitch. All right, let's tackle the next big challenge, quality. It's not enough to just keep the machines running. You've got to make sure every single part that comes off that line is absolutely perfect. Now, a human inspector is incredibly skilled, don't get me wrong, but the scale of modern manufacturing is just mind-boggling. We're talking about trying to find microscopic flaws consistently day in and day out across millions and millions of units. It's a task that just pushes human perception and endurance right to the absolute limit. Now, look at this. This is a perfect example of how an AI sees. This system isn't just taking a snapshot. It's using advanced computer vision to analyze all those tiny metallic chips left over from a process. It identifies them, it calculates the most efficient way to clear them out, and then it executes the cleaning. This is quality control happening in real time at a speed and precision that is, for all intents and purposes, superhuman. And get this, the precision is something you can actually measure. The research shows that these AI models can predict the final quality of a product, say the thickness of a sheet of metal, with an error margin of just 5%. What that means is the system can make tiny adjustments during the process, ensuring almost perfect quality before a part even gets close to a final inspection. Okay, so the machines are running flawlessly, the quality is perfect. But now we come to maybe the biggest puzzle of all, scheduling. How on earth do you orchestrate thousands of different jobs, parts, and machines in the most efficient way possible? I think the best way to think about it is like a massive three-dimensional chess game. But in this game, thousands of pieces are all moving at the same time, and each one has its own unique rules and destinations. Every single decision you make, which job runs on which machine and when, sends ripples through the entire system. So to solve this monster of a puzzle, engineers are using a really cool type of AI called reinforcement learning. Here's how it works. You basically let the AI play this super complex factory chess game millions of times inside a simulation. When it makes a smart move that improves efficiency, it gets a little reward. When it makes a dumb move that creates a bottleneck, it gets a penalty. And over millions and millions of trials, it literally teaches itself the perfect strategy. And this right here is the AI's virtual training ground. You see the RL agent? That's our brain. It tries something, an action, like a new production schedule. It sends that action into a simulated version of the factory. The factory then reports back its new state and gives the AI a score, that reward or penalty. This creates a relentless, continuous loop of trial, feedback, and improvement, all happening at lightning speed before it ever touches a real machine. And the results? Well, they're just stunning. Look at this. On the top, you can see a schedule that was created with older methods. It's kind of chaotic, all over the place. But on the bottom, that's the AI-optimized schedule. It's dense, it's organized, and according to the research, this approach led to a 23% reduction in the total time it took to finish all the jobs. In manufacturing, that is a massive leap in efficiency. So up to this point, we've basically seen AI as this brilliant advisor, right? It predicts, inspects, it plans, but the next step is already happening. So what happens when the AI goes from just advising to acting, when it actually takes the controls itself? Well, welcome to the world of Agentic AI. These are autonomous systems, or agents, that don't just ping a human to say, hey, there's a problem. No, they analyze the options, and then they execute the solution all by themselves. What's so fascinating here is the output. The AI is analyzing a machine breakdown, but notice its potential actions. Machine repair, module swapping speed-oriented, module swapping capacity-oriented. It's not just flagging an error code, it is weighing complex strategic trade-offs and making the best decision on its own. This creates a completely new kind of workflow. Step 1, the AI predicts a failure is about to happen. Step 2, it acts autonomously. It reroutes other jobs around the failing machine, it automatically orders the replacement part, and it schedules the repair. And finally, step 3, it informs its human colleague that a problem was detected and has already been solved. The human's role completely shifts from being a firefighter to being a systems supervisor. So, of course, this brings us to the biggest question of all. Where do people fit into this new picture? I mean, is this whole story really just about replacing humans? Well, the research points to a very, very different answer. Everybody, meet the cobot, which stands for collaborative robot. Now, this isn't some robot locked in a cage that takes over a job. It's a wearable exoskeleton that's designed to work with a human, augmenting their strength for really tough tasks. It's all about combining the raw power and endurance of a machine with the intelligence, dexterity, and problem-solving skills that only a person has. And you don't have to take my word for it. The paper itself makes this point crystal clear. The authors state that, quote, human workers are still needed in the foreseeable future to handle operations that require flexibility and dexterity. Those are things that are still incredibly hard for robots to do. So I think the real takeaway here is that we have to update our mental model. That outdated narrative of man versus machine, this story of competition and replacement, that's old news. The new reality, what's actually happening on the factory floor, is man with machine. It's a story of collaboration and augmentation. Which leaves us with one final and I think really fascinating question. As AI starts to take over all the tedious work, the optimization, the maintenance, the scheduling, it frees up human ingenuity to tackle much higher level challenges. If you don't have to worry about just running the factory anymore, you can focus on completely reinventing it. So as these systems become self-healing and self-optimizing, what new frontier for human creativity are we going to discover next?